Right now, your head is aging faster than your feet. Not metaphorically, measurably. If you have spent most of your life standing upright, walking around, sitting, being a vertical creature on a planet, then the top of your skull has lived through more time than the soles of your feet. Not by much, by a few hundred billionths of a second, spread across a lifetime. It sounds like nothing. It sounds like a rounding error the universe would never bother to keep. But it keeps it. Physicists have measured exactly this kind of difference, using two atomic clocks placed barely a foot apart, one just slightly higher than the other. Raise a clock and it runs faster. Lower it and it runs slower. Move it by the length of your forearm and the effect is already there, sitting in the data, undeniable. The universe keeps that receipt down to the last decimal. Now, here is the thing. Most explanations of relativity stop right about here. They hand you the fact and they walk away. Time runs slower near mass. Time runs slower when you move fast. Einstein. Genius. Mic drop. Roll the credits. But that is not an explanation. That is a fact wearing the costume of an explanation. Because it leaves the actual question completely, totally untouched. Why? Why should a lump of iron, sitting there in empty space, minding its own business, reach out and touch something as abstract, as bloodless, as immaterial as time? Why should simply changing where you are, moving through space, the most ordinary thing you can do, cost you seconds off your own life? What is the machinery underneath all of it? Tonight, we go under the hood. And I want to make you a promise, not a vague one, a specific one. By the end of this video, you are going to understand, really understand, in your body, the way you understand that a dropped glass is going to hit the floor, why an apple falls. And the answer is going to have almost nothing to do with force.
And almost everything to do with the fact that, at this exact moment, whether you like it or not, whether you can feel it or not, you are hurtling through the universe at the speed of light. Yeah, we will get there. Stick with me. So let me tell you where all of this is coming from, because I am not a physicist, and I would never want you to think I am. I am a guy who read some books and could not sleep afterward. The first one is by Brian Greene. It is called The Fabric of the Cosmos. It came out in 2004, and Greene is the real deal. A professor at Columbia, one of the people who actually works on this stuff at the level where the mathematics bites back. But the reason I keep returning to this particular book is not the credentials. It is that Greene can write. Most physicists, God love them, write like they are being charged by the word and want to save money. Greene writes like he genuinely needs you to see the thing he is seeing. And there is one idea in that book, one image, that reorganized my entire understanding of what is going on when we talk about time. I am going to hand it to you tonight. It is the spine of everything that follows. The second book is older, weirder, and honestly kind of a cult object. It is by a man named Lewis Carroll Epstein. Yes, that is his real name, and it is called Relativity Visualized. It came out in 1985, and it is the source of a single diagram that, once you see it, you cannot unsee. Almost nobody on YouTube uses it. It is the most intuitive picture in this entire subject, and it is just sitting there, underexposed, waiting. That diagram is my secret weapon tonight, and when we get to it, you will feel a click somewhere behind your eyes. I promise you that, too.
Here is my honest relationship to both of these. I do not follow every equation in them. There are pages of Greene I have read 4 times and still only half hold.
There are moments in Epstein where I think, hold on, is that a cheat? Is that really allowed? And then I go and check, and it turns out, no, it is not a cheat. It is just the truth said simply, which always feels like a cheat when you are used to the truth being said in a way that hurts. So I am not standing above this material. I am standing next to you, pointing at it, going, look at that. Look at what these people figured out. Okay, under the hood we go. Let us start with the receipt, because I want you standing on solid ground before I take the ground away. There are actually 2 different ways to slow down time, and they are worth separating cleanly because they come from 2 different places, and for most of this video, we are going to be chasing how they turn out to be the same thing. The first kind comes from motion. Move fast, and your clock runs slow relative to someone who stayed put. The second kind comes from gravity, or, more carefully, from being near a lot of mass. Sit deep in a gravitational well, close to a big heavy planet, and your clock runs slow relative to someone up high where the pull is weaker. 2 flavors, motion and gravity. Hold both. Now if this were just theory, you could wave it away. But it is not theory. It is engineering. It is in the machine, in your pocket. In 1971, 2 researchers named Haffel and Keating did something that sounds like a bar bet. They took atomic clocks, actual cesium clocks, the kind that define what a second is, put them on ordinary commercial airplanes, and flew them around the world. Once heading east, once heading west. Then they brought them home and compared them against the reference clocks that had stayed on the ground at the U.S. Naval Observatory. The flying clocks disagreed with the stationary ones, by exactly the amount the equations predicted. Fractions of a millionth of a second, but there, measured, printed, real. The clocks that had flown had genuinely experienced a different amount of time than the clocks that had stayed home. And here is the detail that gets me every time. The eastbound and westbound flights disagreed with each other too, because one of them was moving with the Earth's rotation and one against it. So their speeds through space were different, so their times came out different. The universe was doing bookkeeping at the level of airline schedules. But the real proof, the one you personally depend on, probably several times a day, is GPS. The satellites that tell your phone where you are sit about 20,000 kilometers up. Way up there, the gravitational pull is weaker, so by the gravity effect, their clocks tick faster than yours down here on the surface. But they are also screaming around the planet at thousands of meters per second, so by the motion effect, their clocks tick slower. The 2 effects do not cancel. They land on a net of roughly 38 millionths of a second per day. Fast. 38 millionths of a second. Per day. Who cares, right? Here is who cares. Light, and the signals these satellites use, travels about 30 centimeters in 1 billionth of a second. So 38 microseconds of clock error translates into a position error that piles up at something like 10 kilometers per day. Per day. If engineers did not build Einstein directly into the software of the GPS system, if they did not correct for the fact that time runs at different rates up there versus down here, your navigation would drift by 10 kilometers within 24 hours and be functionally useless within minutes. Your map would confidently place you in the next town over and get worse from there. So let me say this plainly. Relativity is not a philosophy seminar. It is not a thought experiment about twins that you are free to disbelieve. It is a correction term in a piece of infrastructure that billions of people trust with their lives.
The receipt is real. The universe cashed the check decades ago. Huh. Okay, so it is engineering, not philosophy. But now the question sharpens, doesn't it? Because knowing that it happens does not tell you why it happens. And this is where almost everybody makes the same wrong turn. Here is the wrong turn. It is so natural that I made it myself, and I bet you are about to. When you hear that a moving clock runs slow, the tempting thought is, well, sure, moving must jostle the mechanism, shake up the gears, rattle the pendulum. Motion does something physical to the machine, and the machine keeps worse time. It is a mechanical hiccup. Reasonable, sensible, the kind of explanation that lets you go back to bed. And it is completely wrong. And I can prove it to you with one of the most beautiful little facts in all of physics. Meet the muon. A muon is a subatomic particle, a heavier cousin of the electron. It is deeply unstable. Left alone, an average muon exists for about 2 millionths of a second before it decays into other particles and vanishes. That is its lifespan. That is baked into what it is. Now, muons are created constantly, high in the upper atmosphere, when cosmic rays, particles flung across the galaxy from exploding stars and worse, slam into the air about 15 kilometers above your head. These muons are born screaming downward at very nearly the speed of light. Do the arithmetic. A particle that lives 2 millionths of a second, even traveling at light speed, should make it about 600 meters before it dies. 600 meters, from a starting height of 15,000. The muon should never, ever reach the ground. It should evaporate miles up every single time. But it reaches the ground. We detect these muons at sea level constantly.
Right now, several of them are passing through your body every second. They are here. They made the trip. How? Because they are moving so fast that their internal clock, the countdown to their own death, genuinely runs slow. From our point of view, standing on the ground, the muon's 2 millionths of a second lifespan gets stretched out long enough to cross the whole distance. And here is the part that kills the wrong turn stone dead. A muon has no gears. It has no pendulum, no springs, no mechanism to rattle. It is a fundamental particle, about as close to a featureless point as nature offers. There is nothing inside it to jostle, and yet its clock slows down anyway, by exactly the predicted amount, precisely enough to let it reach the ground and be counted. So it was never about the device. Slow a clock down, and it is not that the clock broke. It is that time itself, the actual quantity that clocks are honestly reporting, ran slow. The muon is not a broken watch. The muon is a truthful witness. And its testimony is that time bends. Let that settle for a second, because we just eliminated the comfortable explanation. There is no mechanical hiccup to hide behind. Whatever is happening to time, not to timekeepers. So what on earth is happening to time? The whole thing, all of it, motion and gravity and apples and black holes, grows out of one brute fact. One. And I need you to hold on to it the way you would hold a railing on a staircase in the dark, because we are about to descend. Here is the fact. The speed of light is the same for every observer, no matter how they are moving. Read that again slowly, because it does not sound like a big deal, and it is secretly the strangest sentence in science. In everyday life, speeds add up,
If you are on a train doing 60 and you walk toward the front at 3, then someone on the platform sees you doing 63. Obvious. Intuitive. The way the world works. Now shine a flashlight forward from that train. You would expect the platform to measure the light going at its normal speed plus the speed of the train. It does not. The person on the platform measures the light going at exactly the same speed as you do on the train. Not plus the train, not minus anything, the same. You can run toward a beam of light or flee from it as fast as you like, and it makes not one particle of difference. The light approaches you at the same fixed speed every time. The universe has one speed it will defend at absolutely any cost, and that speed is the speed of light. Now, here comes the thought experiment that unlocks everything, and I want you to actually build it in your mind, not just nod along. Imagine a clock, but a very particular kind of clock, a light clock. It is just two mirrors facing each other, one on the bottom and one on top, with a single pulse of light bouncing straight up and down between them. Up, down, up, down. Every bounce is one tick. That is the whole clock. Simple, honest. It measures time by the travel of light. Now put that clock on a train and get the train moving fast, and watch it from the platform. From your seat on the train, the light just goes straight up and down, like always. Tick, tick, tick. Nothing weird. But from the platform, while the light is traveling up to the top mirror, the whole clock has also moved sideways along with the train. So from the platform, the light does not go straight up. It goes diagonally, up and forward, a longer path, a zigzag. And now, spring the trap. The light on that platform has to travel a longer diagonal path, but it is not allowed to travel any faster. Remember, the speed of light is the same for everyone. That is the one rule the universe will not break. Longer path, same speed. There is only one thing that can give. The tick takes longer. From the platform, the moving clock ticks slower. Not because it broke, not because the light got tired, but because the light had farther to go and was forbidden from hurrying. Time on that train stretched out to protect the speed of light. That is it. That is the entire engine. Everything else in this video is just following this one fact downhill. The universe pins the speed of light in place, and to keep it pinned, it is willing to bend time, stretch it, redistribute it, whatever it takes. Time is the thing that flexes so that light never has to. But I promised you a picture, and here is where Greene and Epstein walk in and change how you see reality. Okay, this is the first big turn. Take a breath. Here is the idea, and it is going to sound like nonsense for about 10 seconds, and then it is going to sound like the most obvious thing you have ever heard. You are always moving through spacetime at a single fixed speed, and that speed is the speed of light. I know, you are sitting in a chair. You are not moving at all, let alone at light speed. Bear with me, because the trick is in the word spacetime. Epstein's picture, the one from Relativity Visualized, asks you to stop thinking of space and time as two separate things, and start thinking of them as two directions you can move in. Directions on one single map. And on that map, everything, you, me, that chair, a photon, a passing muon, everything moves at exactly one speed. The speed of light. Always.
no exceptions. The speed never changes. The only thing that ever changes is the direction. Picture a speedometer, but instead of measuring how fast you are going, it measures which way you are pointed on this space and time map. The needle is always pinned at maximum, at the speed of light. It can never slow down, and it can never speed up. All it can do is rotate. It can point more toward the space direction, or more toward the time direction, or anywhere in between. But the total is always the same. Always maxed out.
Now watch what this does. When you are sitting perfectly still, not moving through space at all, where is all your motion going? It has to go somewhere. The needle is pinned at max, so it points entirely in the time direction. Every bit of your fixed cosmic speed is spent traveling through time. That is what sitting still is. It is moving through time at the maximum possible rate. When you feel like you are doing nothing, you are actually racing through time as fast as anything in the universe can go. And now you start to move through space. You get up, you walk, you get on a rocket, whatever. To move through space, the needle has to rotate. It has to steal some of its pointing from the time direction and aim it at the space direction instead. There is no other way to do it. The speed is fixed. If you want motion through space, you have to take it out of your motion through time. And so your clock slows down. Not because it broke, not because of gears, because of bookkeeping. Because there is a cosmic budget, and space and time are drawn from the same account. And every dollar you spend moving through space is a dollar you cannot spend moving through time. That is why moving slows your clock. Not a rule imposed from outside, not a weird quirk. It is the only way to keep everyone's total space-time speed pinned at the speed of light. Fast through space necessarily means slow through time. It could not possibly be otherwise. Once you see the needle, the whole velocity story stops being mysterious and starts being inevitable. And this is the answer to the promise I made you at the very start. When I said you are hurtling through the universe at the speed of light right now, this is what I meant. You are. You are doing it in the time direction. Every second, you travel 1 second into the future at the maximum rate the universe allows. You have never once in your entire life gone slower than light through space-time.
None of us has. We are all going flat out all the time. We just usually point ourselves almost entirely at tomorrow. I had to put the book down when I got this. I just sat there, because it reframes stillness itself. Sitting quietly in a chair is not the absence of motion. It is motion, pure motion, aimed straight at the future. All right, we have motion handled. We understand now, really understand, why moving through space costs you time. 1 flavor down. But there were 2 flavors, and the second one, gravity, is where this stops being a clever bookkeeping trick and becomes something that will genuinely rearrange your sense of what is real. To get there, we have to follow Einstein into what he later called the happiest thought of his life. His words, more or less. The happiest thought he ever had. And it is this: a person in freefall does not feel their own weight. That is the whole thought. Sit with how strange it is that this made him happy, because at first, it sounds like nothing. Imagine you are in an elevator, and the cable snaps. I know, dark. Stay with me. Nobody gets hurt in a thought experiment.
The elevator is now falling freely down the shaft, and you are falling inside it. What do you feel? You feel weightless. You float. If you had a coin in your pocket and you took it out and let go of it, it would not drop to the floor. It would just hang there in the air beside you, floating, because it is falling at exactly the same rate you are. From inside that elevator, with no windows, you would have no way to tell whether you were plunging toward the Earth or drifting in the deep of space, far from any planet, in perfect weightlessness. The two situations would feel identical, utterly, completely identical. And Einstein flipped that around and pulled a thread that unraveled the cosmos. Because if falling freely feels exactly like floating in empty space with no gravity, then turn it inside out. Imagine you are in that same windowless elevator, but now it is out in deep space, far from everything, and a rocket underneath it fires and accelerates it upward. You would be pressed to the floor. Take out your coin, let it go, and it drops to the floor, because the floor is rushing up to meet it. And from inside, with no windows, you would swear you were simply standing in a box on the surface of a planet, held down by gravity. Acceleration and gravity are indistinguishable. There is no experiment you can do inside the sealed box to tell them apart. They are not similar. They are the same thing. This is what physicists call the equivalence principle, and it is one of the deepest ideas any human has ever had. Now, do you feel the trap closing? Because we already know exactly what motion and acceleration do to time. We just spent 10 minutes on it.
Motion through space slows your clock. And Einstein just told us that gravity and acceleration are the same phenomenon wearing different clothes. So whatever motion does to time, gravity has to do too. Gravity must bend time, not as a separate weird bonus effect, as the same effect. If acceleration is indistinguishable from gravity and acceleration warps time, then gravity warps time by sheer logical necessity. We did not even need new physics. We just needed to notice that the coin floating in the falling elevator and the coin dropping in the rocket are telling us that these two things we thought were different are one thing. Two flavors, and they just collapsed into one. Okay, this is it. This is the deep turn, the one the whole video has been climbing toward, and I need you fully present for the next 4 minutes because we are going to build something brick by brick, and at the end of it, the ground is going to move. We have established that gravity bends time. Mass. A planet, a star, your own body, anything with heft, makes time run at different rates at different distances from it. Close to the mass, deep in the well, time runs slow. Far away, up high, time runs faster. The atomic clocks 1 foot apart proved it. Your head and your feet prove it. Down low, near the Earth's mass, time drags. Up high, it hurries. There is a slope. Time is not flat around a planet. It is tilted. Hold that word. Slope. Tilted. Now I need to give you one more piece, and it is the most beautiful principle in this whole business. Every object moving freely, no rockets, no forces pushing on it, just left alone, travels through spacetime along a very specific path. And the rule that picks the path is almost poetic. Out of all the possible routes it could take between where it starts and where it ends up, a freely moving object follows the one path that lets it age the most. The path of maximum experienced time.
Physicists have a name for it. The geodesic. But forget the name. What matters is the meaning. Left to itself, everything in the universe takes the route through spacetime that maximizes its own aging. Everything is, in a sense, quietly trying to experience as much time as it possibly can. Now put the two pieces together. Slowly. This is the moment. Piece 1. Time runs slower down low, near the mass, and faster up high. There is a slope in time. Piece 2. A free object always steers itself toward the path where it ages the most. So picture something up high, an apple hanging in the air. It wants to take the path of maximum aging. And down below it, closer to the Earth, time runs slower. But that also means the geometry of spacetime is tilted, and the path that racks up the most total aging actually bends the object downward, toward the region where time runs slow, because of how the slope of time curves the available routes through spacetime.
The apple, seeking to maximize its own experience time, is steered by the tilt of time itself, and the direction that tilt points it is down. The apple falls, not because the earth grabbed it, not because a force reached up and pulled, but because it is following the natural path through a region where time is sloped, and that path bends toward the floor of the well. And now, the punchline. Stated flat, no drama, because it does not need any. The strength of gravity you feel, the exact force pinning your feet to the floor right now, is literally the steepness of the time slope, the gradient of time dilation. Where time changes rapidly from place to place, gravity is strong. Where time is nearly flat, gravity is weak. Gravity is not a force added on top of time. Gravity is the slope of time. It is what the tilt of time feels like from the inside. Holy. Okay. Let me say it a different way, because I do not want you to think I am being poetic. I am not being poetic. This is the actual weak field result. It is in the Feynman lectures on physics, spelled out in the plain mathematics. And here is the part that genuinely rearranged my head when I learned it. For everyday objects, apples, raindrops, you and me, anything moving slowly compared to light, it is almost entirely the curvature of time that makes us fall. Not the curvature of space, time. The bending of space matters for things moving near light speed, like the bending of starlight around the sun. But you, standing there, you are held to the earth by the slope of time. Overwhelmingly, time is doing the work. And if this is the kind of thing that reorganizes your evening, if you are the sort of person who wants the real machinery and not just the fact in a costume, then subscribing is honestly a reasonable decision. Because this channel only exists because enough people wanted to keep going down exactly this kind of hole. And where we are headed next is stranger still, because we still have not closed the loop I opened at the very beginning. We still have not fully answered why the apple falls. We are one step away. Let me take it. Here it is, the whole thing all the way home. The apple does not fall because the earth reaches up and grabs it. Nobody is grabbing anything. There is no rope, no hand, no invisible pull. The apple falls because it is drifting toward the region where its own clock ticks slowest. And, given the shape of space-time around a planet, it cannot do otherwise. It is following the path of maximum aging, and that path points down, into the valley of slow time, toward the floor of the well. Falling is not the apple being yanked. Falling is the apple going straight, moving in the straightest possible line it can, through a spacetime that has been tilted by mass. From the outside, that straight line through curved time looks like a curve, looks like a fall. But from the apple's point of view, it is doing the most natural, most unforced thing imaginable. It is coasting. It is going straight ahead through a world where straight ahead happens to point down. And now, the part that should make the hair on your arms stand up. Your feet are pinned to the floor for that exact same reason. Right now, sitting or standing wherever you are trying to fall. Every cell of you is trying to take the natural path, straight through space-time, down toward the floor of the time well, toward where your clock runs slowest. That is what you want to do. That is the free, natural, unforced motion. The only reason you are not falling is that the ground is in the way. The floor is physically shoving up against your feet, stopping you, holding you out of your natural free-fall path. The pressure you feel in your feet right now, the weight in your body, the thing you have called gravity your entire life, that is not the earth pulling you down. That is the ground pushing you up, refusing to let you fall the way space-time is quietly urging you to. Read that again if you need to. The sensation of weight is not gravity pulling. It is the floor stopping you from following the slope of time. The astronaut in orbit feels weightless not because there is no gravity up there. There is plenty, but because nothing is stopping them. They are in free fall, following their natural path, coasting through curved time, and it feels like nothing at all. It feels like peace. Weightlessness is what following the slope of time feels like when nobody is in your way. And the weight you feel this instant is the opposite. It is the sensation of being prevented. We have spent your whole life telling you a story about a force, and there is no force. There is a slope, and you are leaning against it every second of every day, and you have simply always called that leaning your weight. And here is where I have to come back and tell you the truth about a picture you have seen 1,000 times. Because I promised, way back near the start, and I do not want to let it slide. You know the picture. The bowling ball on the trampoline. A heavy ball sits in the middle of a stretched rubber sheet, making a dip, and a smaller marble rolls around the dip, and the voiceover says, "See, that is how mass curves space and makes things orbit." I want you to notice something devastating about that picture. Ask yourself, why does the marble roll down into the dip in the first place? Why does it fall toward the bowling ball? Because of gravity. Because the whole trampoline is sitting on the floor with real Earth gravity pulling everything downward. The picture uses gravity to explain gravity. It smuggles in the very thing it claims to be explaining, hides it under the table, and hopes you will not check. If you took that trampoline into deep space, with no gravity pulling the marble into the dip, the marble would just sit there on the rubber sheet, or drift straight across it, completely ignoring the bowling ball. The demonstration only works because it is standing on a planet, cheating with the exact force it pretends to derive. And worse, much worse, the trampoline shows you curved space, a bent two-dimensional sheet. And we just spent this entire video learning that for you and me and every falling apple, it is barely about curved space at all. It is about curved time. The trampoline picture does not just cheat, it points you at the wrong dimension. It hides the real answer, time, behind a pretty picture of the wrong thing. For decades, that image has been the standard way this idea is taught, and it is one of the most misleading pictures in all of popular science. Now you know why. Now you can never watch it the same way again. So let me pull all the way back, because I think you can feel the video quietly changing shape underneath you. You clicked on this, thinking it was a video explaining a physics fact, a neat bit of trivia about clocks and altitude. But that is not what this was about. It was never about the fact. It was about what time and gravity fundamentally are. Gravity, it turns out, is not a thing that acts on you. It is not a force in the universe. It is a feature, a shape, of time's uneven flow. And motion and gravity and time are not three separate phenomena that happen to be related. They are three faces of one single geometric object. Move through space, slow through time. Sit near mass, slow through time. Fall and follow the slope of that slowness. It is all one thing, seen from different angles, the way a mountain looks like different mountains from different valleys, but is only ever the one mountain.
And underneath even that, there is a quieter and more unsettling thing this whole climb has been building toward. And I want to say it plainly, because it is the strangest part, and it usually gets left out. There is no universal now. We move through life assuming there is a single cosmic present moment, a now that everyone in the universe shares, a single slice of time that is happening everywhere at once, and we are all riding it forward together. There is not. Because time runs at different rates for different observers, moving differently, sitting at different depths in different wells. There is genuinely no fact of the matter about what is happening right now, somewhere far away. Your now and my now can honestly differ. The present is not a shared universal thing that the cosmos is experiencing together. It is local. It is personal. It bends. Time is not the stage the universe performs on. We always imagined it that way. A fixed backdrop, a river flowing at one steady rate, indifferent, universal. The same for the apple and the star and the muon and you. It is not the stage. Time is one of the players. Time is the thing that moves and tilts and pools and slopes. It is not the container. It is part of what is inside. So let me bring you all the way back to your own body, where we started. You began this video knowing one strange, small fact. Your head ages faster than your feet. It seemed like a curiosity, a party trick of the cosmos, too tiny to matter. Now you know why, and it is not small at all. The entire planet beneath you is a valley in time, a well. Its floor, the center of the earth, is where clocks run slowest, where time pools deepest, and its walls rise up and away in every direction to where time runs quicker. And you, every cell of you, every atom, your slow-timed feet and your faster-timed head, you are perpetually, gently, ceaselessly, sliding toward the bottom of that valley. You have been sliding your whole life. You cannot climb out. You never could. The ground under your feet is the only thing that has ever stopped you from reaching the floor, and the moment it gives way, you resume the fall you were always in the middle of. Every apple that has ever dropped from a branch, every raindrop, every stone, every collapsing star folding in on itself across the dark. Every one of us, every single day, from the moment we are born to the moment we stop. All of it, all of us, just following time downhill. Gravity was never a force reaching up to hold you against the earth. Gravity is just the places where time pools deepest. And an apple falling is the most honest, most natural, most unforced motion there is. A thing going straight ahead through a world where straight ahead points down. And a black hole? A black hole is where that gentle slope becomes a cliff, where the tilt of time steepens and steepens until it goes vertical, where time does not merely run slow, but slows and slows and finally stops. A place where the valley has no floor, where the slope falls forever. Which leaves us, you and me, with one last question, and I am going to hand it to you, and then I am going to let you go, because I genuinely do not have the answer, and I am not sure anyone does. If falling is just following time downhill, what does it mean to fall toward a place where time itself runs out? Sleep on that one.